All right, so we can proceed with our topic, no? So we proceed with the first chapter of our subject, Geometry 1-3, Numerical Methods and Analysis, no? So in this, so this is the previous slide I have presented, no? I have told you before that uh, we will employ the Microsoft Excel software, no, program to solve problems, no, regarding our subject. So chapter 1, we have solutions to systems of linear equations. No? So you're familiar with this, and the conventional way of solving such equations are performed in your previous subjects, no? Like in circuits, no? So you're solving three equations, three unknowns, using the classical method, no? However, there are alternatives to that, no? And we'll talk about that in the near future. So for now, I will introduce the introduction, no, to this topic. So introduction and properties of determinants and matrices. Okay. So I'm going to discuss about properties of determinants and matrices. As stated, systems of linear algebraic equations can be expressed very conveniently in terms of matrix notation. Solution methods for systems of linear algebraic equations can be developed very compactly using matrix algebra. No? So in this case, the linear equations, no, linear equations for the system, we have the system of linear equations, and from that system of linear equations, we will craft a matrix, no? So in terms of matrix notation, as stated, no? From those linear algebraic equations, we will craft or we will make a matrix, no? And later you will know what I'm talking about, no? So solution methods for systems of linear algebraic equations can be developed very compactly using matrix algebra. And then we will apply matrix algebra, no, to solve the solution of that system of linear equations. No? So when we talk about matrix, plural is matrices. This is a rectangular array of elements, either numbers or symbols, no, which are arranged in order the rows and columns. No. So to give you an example, this is a matrix wherein we have considered this has three rows, no? Row number 1, row number 2, and row number 3. Okay? So first row, the second row, and the third row. Then it has also no columns, no? This is called matrix, no? We have four columns. Okay? Column 1, column 2, column 3, and column 4. Okay? So it has three rows and four columns. And it is enclosed in a bracket. No? So we have brackets. No? Okay? So, and this is now matrix A in this example. A is equals to this matrix comprising of the elements. We call 2, 4, negative 2, 10 as elements of the first row, no? 9, negative 3, 3, 0 elements in the second row. Okay? 6, 12, negative 5, negative 1 elements in the third row. No? So then we have 296 elements in the first column. For negative 312 elements in the second column. Negative 2, 3, negative 5 elements in the third. And then 10, 0, negative 1 elements in the fourth column. No? So in this case, the size of a matrix is specified by the number of rows times the number of columns. No? So that is how we specify the size of the matrix. We use number of rows and number of columns to describe the size of the matrix. No? So in this case, a matrix with n rows and m columns is said to be an n by m or n by m matrix. No? So by here can be written in terms of the multiplication symbol. No? N times m. But we read it as n by m. Parang index card. 2 by 2 by 2. Ano bang size ng index card? Na ano na lang, photo na lang, 2 by 2 picture. 1 by 1 picture, di ba? So, yung 2 by 2 na yan, ganyan siya nasusulat. Okay? Hindi siya pinapronounce na 2 times 2. Okay, 1 by 1. Okay? Similar to that, it's analogous to our topic, no? So, in that case, we can now describe the size of this matrix in this example. Using this concept, what will be the size of this matrix I have shown? So the size is, so it has how many rows? 3 rows and 4 columns. Therefore, we can say that this is a 3 by 4 matrix because it comprises of 3 rows, row 1, row 2, row 3, and 4 columns, column 1, column 2, column 3, and column 4. Okay? Now, matrix A in the above example is considered as a 3 by 4 matrix because it has n equals to 3 rows and m equals to 4 columns. Okay? Elements of a matrix are generally identified by a double subscripted lowercase letter. For example, A sub ij. Okay? So we use the two subscripts I and j, where the first subscript I identifies the row of the matrix. Okay? So the element, no, wherein it is placed in that row, that element. It is located at a certain row. No, identifies the row of the matrix, and the second subscript J identifies the column of the matrix. So in our example, if we have 2, it's located in the first column and at the first row. Or should I say, mauuna yung row na I, then J. So it's located at the first row, followed by at the first column. If I have here 3, it's located in the second row, third column. Okay? So I here is 2, J here is 3. Second row, third column. I have 12. I have A location is at the third row and second column. Okay? So that is the interpretation. So we can proceed. So this will now be the representation. Okay. So I have negative 1, and that is the element in the third column, sorry, in the third row and fourth column. I have 0, the element in the second row and fourth column. No. So that's it. So we can proceed. And then there are some special matrices to consider. First are vectors. Okay. Second are square matrices. Third, diagonal matrices. Fourth, identity matrices. Fifth, triangular matrices. No? So for a square matrix, diagonal matrix, identity matrix, triangular matrix, and vector, so you should be familiar with this, no? Yung mga ano, ito. Okay? So that yung mga sa board exam kasi minsan lumalabas yung mga yan, no? So vector matrix, so when we talk about vectors, these are special types of matrices which has only one column or one row, no? So single vector, a single column or single row, no? So if the matrix has a single row or a single column, we call it as a vector, no? So if first we consider the column vector. A column vector is an n by 1 matrix. Okay, so again, n specifies the number of rows. 1 here is the number of column. No. So in that case, it could be more than one row, but exactly one column. No. So that's one column. N by 1 matrix. So that is a column vector because it has one column. No. For example, okay, we have 1, 2, 3, 4. We have 4 rows. Okay, and we have one column. No, we have one column, and the size now of the matrix is 4 by 1 because it has 4 rows and a single column, and we call this now as vector, specifically column vector, because it has a single column. No? On the other hand, we have row vector. A row vector is an 1 by n matrix. Okay, one row and columns. Okay, for example, if I have here the elements inside this, the elements of this matrix. Okay, we have a11, a12, a13, a14. Okay, these elements are in the first row. No, they are in the first row, and since there is only one row, we consider it as vector. Okay, specifically row vector because it has a single row. So in this case, we have 4 columns in this example. So the size now of this matrix is 1 by 4, no? Because it has one single row and 4 columns. Okay, so alright, so this is a row vector. Then we have square matrix. A square matrix S is a matrix which has the same number of rows and columns. So that is m equals to n. Okay, m equals to n. So that we call that as square matrix. So in this case, This is an example of a square matrix. Okay. Uh, as you notice, this is the pattern. Now, if I have here A11, so the number of columns is the same as the number of rows. If that was satisfied, we call the matrix as square. So until a and n. Okay. So this in this example, this is an n by n matrix. No, this is an n by n matrix. So in this case, this is a 4 by 4 matrix. No, which is a square matrix. No, so comprising of 4 rows and 4 columns. So the left to right downward sloping line of elements, no? Ito, yung left to right dito. So the left to right, from left to right downward sloping line of elements, which consists of A11 to ANN, okay, is called the major diagonal of the matrix. Okay, so this is the major diagonal of the matrix. The left to right downward sloping line of elements. Okay, major diagonal. Okay, so in this example, these are the elements in the major diagonal of this matrix, which is 4 by 4. And this is A11, this is A22, this is A33, and this is A44. Okay, so these are the elements in the major diagonal. So then we have diagonal matrix. A diagonal matrix D is a square matrix with all elements equal to 0 except the elements in the major diagonal. No? So as you notice, we all the elements above and below the major diagonal are all 0. No? Therefore, we can classify this as a diagonal matrix. No? So above the major diagonal, all are zeros. Below, all are zeros. Provided this should be a square matrix. Okay? First criterion, it should be a square matrix. Second, it below and above the major diagonal, they must all be 0. Okay? So that we can able to say that this is a diagonal matrix. No? So it is a square matrix with all elements equal to 0 except the elements on the major diagonals. Okay? So that's it. Then we have identity matrix. Oh, by the way, take note that this can be any number, no? Any they can have any values, no? For an identity matrix, what is an identity matrix? Identity matrix I is a diagonal matrix with unity diagonal elements. In other words, all of the elements in the major diagonal are all equal to 1. No? Unlike in the diagonal matrix alone, no, uh, they can have any value. But this is a special case of a diagonal matrix when all of the numbers are equal to 1. No? we can able to say that the diagonal matrix is an identity matrix. Okay, okay, so that's it. So this is a diagonal, an identity matrix with all elements equal to 1 at the major diagonal. Then we have here also triangular matrix. So a triangular matrix is a square matrix in which all of the elements on one side of the major diagonal are 0. The remaining elements may be 0 or non-zero. Okay, so later I'll show you the example to this. So there are two types. The first is the upper triangular matrix, and the second is the lower triangular matrix. So for us to say that the matrix is triangular, it should be a square matrix first. And then all of the elements on one side of the major diagonal, either right side or left side, or upper side, lower side, no? So they must be all equal to 0, no? All of the elements on one side alone, no? So to illustrate, we have here an upper triangular matrix. So denoted by U has all 0 elements below the major diagonal. So as you notice, this is the major diagonal and all of the elements below it are all 0. Okay? So we can therefore say that this is an upper triangular matrix, provided that all of the elements above it, okay, at least one element must not be equal to 0. Okay? At least one element must not equal to 0. Okay? So we can therefore say that this is an upper triangular matrix. For a lower triangular matrix, so denoted by L, it has all 0 elements above the major diagonal. Okay? So we have the 0 elements above the major diagonal. Okay? So we can therefore say that this is a lower triangular matrix. Okay? This is a lower triangular matrix. So provided that at least one element below the major diagonal must not uh, must not at least one element must be equal to must not be equal to 0, no? So sabihin dapat kahit isa lang diyan ay hindi 0, sabihin na pwedeng 1, no? Tapos yung iba 0, pwede 'yan. So pwede 'yan. So we can still classify it to be a lower triangular matrix, no? So we can proceed to transpose of a matrix. So I'm done with the special matrices. So we have here transpose of a matrix, no? So we have here transpose of an n by n matrix. A is the m by n matrix. Okay. So we have A with the superscript, no? A with the superscript. So A with the superscript T, denoting that matrix A is transposed. Okay. So in other words, there is the number of rows and the number of columns are interchanged. Okay, so in this case, we have n rows and we have m columns. This is the original. It becomes now m rows and n columns. Okay, so the transpose of n by m matrix A is the m by n matrix A superscript T, now with the superscript T. So which has elements? Okay, this one we have T for the transpose. No, so transposing. So this element Aij, okay, when transposed becomes Aji. For example, if I have A12 when transposed, that will be A21. Okay, so I will illustrate later. So one has to interchange the value of the column with the row subscripts. No? So, so the transpose of a column vector is a row vector and vice versa. Okay? So in this case, one has to interchange the value of the column and the row subscripts. No? So ito para dito sa Aij when transpose equals to Aji. No? So pagbabalik ta rin lang pag na-transpose. So the transpose of a column vector is a row vector and vice versa. Okay? So column vector mula column vector magiging pag na-transpose magiging row vector. Okay? Pag na-transpose. Okay? So A11, A1, A21, AN1, okay, magiging A11, A12 hanggang A1N. Ayan. Mapapalitan sila. Okay? So one has to interchange the value of the column with the row subscripts. So yung subscript magbabaliktad, no? Okay? Magbabaliktad. Ito, pag binaligtad mo yung 1 and 1, 1 and 1 pa rin naman. No? Okay? I hope you get it, no? So we can proceed. For example, if we are to determine the transpose of the 3 by 3 matrix C, no? So C equals to the matrix with the elements 2, negative 5, negative 1, 7, 6, 4, 0, negative 3, 8. I'll get the transpose of it. So see, what is C transpose? So in this example, so 2, negative 5, negative 1, when we transpose that, we write in they are in the first row. They are in the first row. Now we will write them in the first column. Okay? For the second row, we will write them at the second column. No? And for the third row, third column. Okay? Let's check. This is A12, right? First row, second column. It becomes now A21, second row, first column. Let's check 4. This is A23, second row, third column. It becomes When we transpose, becomes A32. No? Third row, second column. Third row, second column. Okay? Another one, 7. Second, second row, first column. It becomes first row, second column. So the transpose of it is simply A12. Alright? So the answer is this, 270, negative 5, 6, negative 3, negative 148. So that's it. Then another example, the transpose of the 3 by 5 matrix F. Okay, so we just write, okay, so F transpose, we have here 10, negative 3, 9. They are in the first column, so we can write them at the first row. Now, negative 2, 1, 2, we can write them at the second row. Okay, then third column, third row. Okay, and then fourth column, fourth row. Then fifth column, fifth row. Okay, so this will now be the transpose of the matrix F. Okay, so 10, negative 2, negative 5, 0, 7 are now placed in column 1. 10, negative 2, negative 5, 0, 7. Negative 3, 1, 3, 0, 4 are now placed at the second column. Negative 3, 1, 3, 0, 4, and so forth. No? So this is now the answer. Alright, then we have matrix algebra. So matrix algebra consists of matrix addition, matrix subtraction, and matrix multiplication. So matrix division is not defined. So that's the property of matrix algebra. Now, there can be matrix addition, matrix subtraction, matrix multiplication, but no matrix division. No? So for matrix addition and subtraction, it consists of adding or subtracting the corresponding elements of two matrices of equal size. No? Unequal size matrices cannot be added or subtracted. Okay, so the corresponding elements can be added. For example, if I have the two A11, A12, okay, A21, A22, adding it to another matrix, say B11, B12, B21, B22. So in this case, the result will be excuse me. So excuse me. So we have here corresponding elements. Okay, we can add the corresponding elements provided they should have equal size. What's the size of the first matrix? 2 by 2. 2 rows, 2 columns. Second matrix, 2 by 2. So since the sizes are the same, the next step is to add those matrices. We need to add the corresponding elements. No, we will add the corresponding elements. So A11 and B11 are the corresponding elements. Okay, so A11 plus B11, then A21 plus B21. Okay. then A12 and B12, then A22 and B22. Okay, and if this is subtraction, we just place this by minus. A11 minus B11. So this will be minus. Okay, there. Okay, minus. So that's it. By the way, if they have an equal size, if the two matrices are unequal in size, they cannot be added or subtracted. Take note of that. Now, so for example, if I have this problem, add the two 3 by 3 matrices A and B to obtain the 3 by 3 matrix C. Okay, where A is equals to this matrix and B is equal to that matrix. So in this case, A plus B, so simply as that. One, first, we have to satisfy the condition that they are of the same size. And the size of the first matrix, 3 by 3, the second matrix is 3 by 3 as well. And we can now add the corresponding elements. 1 and 3, they are both in the first row, first column, right? So we can call them as corresponding elements because they are in the same row, same column. Okay, so 1 plus 3. 2 and 2 are also corresponding elements. So we add those. 3 and 1, okay, and so forth until you reach 3 and negative 1. Okay, and this will now be the result. Okay, and this will be our answer. Simply as that. Now, now for the second example, so given the following matrices, no, uh, A, we have this matrix, and B, we have this matrix. Evaluate the following: A plus B, A minus B, and B minus A. For A plus B, so since they are of the same size, we can add the corresponding elements. Okay, we have 5 and 2, 6 and 1, and so forth until you reach 0 and negative 2. Okay, A minus, so this will now be the answer. Then for A minus B, so we just replace plus by minus. 5 minus 2, then 6 minus 1 until you reach 0 minus negative 2. Then you will obtain this answer. For B minus A, it's the opposite. So it's B minus A, 2 minus 5, 1 minus 6, okay, until you reach negative 2 minus 0. Okay, I hope you get it. And you will get this answer. Okay, let's now proceed to matrix multiplication. So matrix multiplication consists of row element to column element multiplication and summation of the resulting products. So multiplication of the two matrices A and B is defined only when the number of columns of matrix A is the same as the number of rows of matrix B. Okay, so I'll illustrate this later, no, yung process. Okay, so there is a note that It is defined only when the number of columns of matrix A is the same as the number of rows of matrix B. No? Pag may multiply mo yung dalawang matrix, A, matrix A times matrix B. So number of yung number of columns ng A dapat kapareho ng number of rows ng B. Okay? Ganun dapat. So, ibig sabihin nito, kung ito ay P by Q, ito ay Q by R. Sabihin, the two must be equal. Q equals Q. No? So, P by Q, Q by R. So, kung ito yung size ng matrix A, P by Q, the size of matrix B must be Q by R. Because this is the number of columns, right? And this is the number of rows. Okay? Number of rows. Okay? And we can only perform matrix multiplication if the number of columns of matrix A, ito, which is Q, is the same as the number of rows of matrix B. Okay? Ito yung matrix B, ito yung number of rows niya. And the two must be equal so that we can perform matrix multiplication. Okay? So, in matrix multiplication, sabi dito, row element to column element multiplication. To illustrate that, row element, column element. Ganito lang yan. Okay? So, let's say, simple example. I have A11, A12, A21, A22, B11, B12, B21, B22. So, in this case, we have row element to column element. So, sabihin nito, ganyan yung direction. To the right, downward. To the right, downward. So, ganyan yung direction na pag-multiply. So, matrix multiplication consists of row element to column element multiplication. Okay? Ito yung row element. So, sabihin niyan, lahat yung row, ito ay isang row element. Sabihin, nasa row 1 ka. Ang reference mo, row 1. Row 1. So, ito yung element na nasa row 1. Okay? Yan yung element na nasa row 1. Ito. Ito yung element na nasa row 1. Okay? Nasa row 1. Ngayon, ito naman ay column element. Sabihin nito, ito yung para sa row, ito yung para sa column. Okay? This is the, ang reference ay column 1. So, this is the column element, B11. Yun ang tinutukoy niya dito. Consists of row element. So, sabihin niyan, ang reference mo ay row 1, halimbawa. Okay? This is a row element. To column element, ang reference ay column 1. So, column element ngayon ito. Okay? Multiplication. So, sabihin niyan, A11 times B11. Multiply natin. Ganun. Okay? Row element to column element multiplication. And summation of the resulting products. O, mamaya yung summation. Tapos, second element, ito, A12. Tapos, B21. Second element sa row 2. Second element sa column 1. Okay? So, row element, column element multiplication. First element, row 1. First element, column 1. A11, B11. Second element, row 1. Second element, column 1. Okay, A12, B21. Then, summation of the resulting products. So, merong product, summation, o add lang natin. Okay, ganun siya. At yan yung bagong element ngayon na doon sa A times B. No? Ito na yung bagong element ngayon na nasa first row, first column. Yung pinagsamang dalawa. Yung pinag-add. No? So, ganyan ang matrix multiplication. So, tapos proceed naman tayo sa next column. Ang next ay column 2, ang reference. At ito yung mga elements na i-consider. Same pa rin naman. Same row, row 1, column 2 naman. A11, B12. A11, B12. Okay? So, row element to column element multiplication. Row to column element. Okay? So, ang reference ay row 1. Ang reference dito ay column 2. A11, B12. Tapos yung isa, A12 and B22. Okay? A12 and B22. Then add, summation. No? Summation. Okay? So, ganun siya. No? Add, summation. Okay? Next. O, tapos ka na doon. Ang next target. No? So, ano ngayon ito? Ito na yung, sabihin natin, matrix C. Yan ay matrix C. Yan yung C11 natin. So, sabihin niyan, C11, nagmula sa row 1 hanggang row 1 at column 1. Row 1 ng matrix A, column 1 ng matrix B. So, magkakaroon ngayon ng subscript na 1, 1 para sa matrix C. Okay? So, C11 yan. Ito naman, nanggaling sa row 1 ng matrix A, column 2 ng matrix B. So, C12. Row 1, column 2. C12. Okay? So, yun yung C12. O, ano naman yung ano dito? C21. Second row, first column. So, sabihin kung second row, lipat tayo dito. Gamitin natin yung sa row 2. Okay? Gamitin natin yung sa row 2. Yan, row 2. So, burahin natin to. Okay, ang gagawin natin, ang reference natin ay row 2. Okay, row 2 and column 1. Reference natin ay column 1. Okay, column 1. Column 1 ang reference. Row 2, reference. 2, 1. Okay, row 2, column 1. O kung ganon, C21, row 2, column 1. So, A21 times B11. Okay. A21, B11 plus A22, B21. Okay. O, ganun kasimple, no? O, next. Next is this, column 2 naman. Okay, kasi ito yung sa C22. So, row 2, column 2. Row 2, column 2. Okay. So, row 2, column 2. So, A21, B12. A21, B12 plus A22, B22. Okay? Ayun, no? So, kompleto na. So, yan na yung matrix C with the new elements C11, C12, C21, C22. That's it, no? So, ganyan ang matrix multiplication. At take note, i-add ko na rin ano yung magiging bagong size sa matrix. Yung natira, P by R. So, this is now a P by R matrix. No, P by R. Yan ang bagong size na matrix natin. P by R. So, kung P by R, ano yung P dito? Ilang rows? Dalawa. Dalawang rows. Yung R dito ay columns. Ilang columns yung matrix B? Dalawa din. Okay? So, sabihin niyan, 2 by 2. So, tama, 2 by 2 nga ito. No? Okay, so so in this case, matrices that satisfy this condition are called conformable in the order AB. No? So, conformable. Okay? So, pagka yung number of columns na matrix A ay kapareho na number of rows na matrix B. The two matrices are said to be conformable. Okay? In the order AB. Okay? So, sabihin, pwedeng i-multiply kasi conformable sila. Okay? If the size of matrix A is n by m and the size of matrix B is n by r, then size of matrix C is n by r. So, yun yung ay paliwanag ko na. Kapag pareho yan, n by r yung ating size ng bagong matrix. Remember that matrices that are not conformable cannot be multiplied. Okay? So, this is the example. I have here matrix A and matrix B. So, we are to get the product AB to get the resulting matrix C. No? So, matrix A is 4 by 3. Matrix B is a 3 by 2 matrix. No? 4 rows, 3 columns. 3 rows, 3 rows, 2 columns. Okay, tama. So, thus, the size of the resulting matrix C is 4 by 2. Conformable ba sila? 4 by 3, 3 by 2. Number of columns is equal to the number of rows. Therefore, they are conformable. Okay? And we can now perform matrix multiplication. No. And the new size will be 4 by 2. 4 by 2 yung new size. So, if that's the case, so 4 by 2, no? So, 4 by 2. Sabihin yan, 4 rows and 2 columns. So, A12, C na pala. C11, C12, C21, C22, C31, C32, C41, C42. Okay? Okay, so in this case, we have to get C11, we consider the first row and first column, row 1 and column 1. Okay, column 1. So row 1, column 1. So row 1 elements times column 1 elements. Ibig sabihin no? Yung corresponding element. No? So 2 times negative 2. No? So 2 times negative 2. Okay. Plus 7 times 3. Plus negative 5 times negative 1. Okay. So pag inad natin yan, yun ang result. No? Magkakaroon tayo ng result. Hanggang makarating tayo sa C42. So sabihin niyan, consider natin yung row 4. Okay? Consider natin yung row 4 hanggang column 2. Okay? Row 4, column 2. Row 4 elements. Consider natin ngayon yung row 4 elements. Ito yung row 4 elements. Row 4 element, now, itong first dun sa row 4. Okay? Tapos yung first din dun sa column 2. No? So 1 times 7, yung ano dito, plus negative 1 times negative 4, plus negative 3 times 1. Ayan, para sa C4. Hanggang doon, hanggang makapunta tayo doon. Okay? So the result is this. No? So yan ang mga result. At ang magiging sagot ay yan. Okay? So that will be our answer. I hope you get it now. So tignan natin. C31. So row 3, column 1. Row 3, column 1. Tignan natin. Row 3, column 1. So row 3, column 1. Ito 4 times negative 2. Row 3, column 1. Ito siya. 4 times negative 2. Ito. Row 3, column 1. 4 times negative 2 plus 2 times 3. Ito 2 times 3. Then negative 2 times negative 1. Negative 2 times negative 1. Makukuha ay 0. Okay? I hope you get it, no? Okay, so during exam, pwede naman kayong Microsoft Excel. Tuturo ko din yan paano yung sa Microsoft Excel na ipoprogram mo siya, no? Isa-simulate mo siya, no? Ayun. So, kung meron kayong para madali yung makuha yung sagot. Pero kung wala kayong laptop, handwritten yung gawin nyo, no? Handwritten. So, try example 2. Okay, I'll give you time. Try example 2. Get the product CE given the following matrices. So, C times E. So, ito yung sagot. Okay. Panikwanan nyo lang na. Okay. So, then we have the topic, determinants. And we're now on determinants. No? Okay, so I think this is not new to you, determinants. No? So, we have a determinant which is 2 by 2. No? A 2 by 2 determinant. So, we get the determinant of a 2 by 2 matrix. No? Uh, so we have a 2 by 2 determinant. We also have a 3 by 3 determinant, which is the determinant of a 3 by 3 matrix. Okay, determinant of an n by n matrix. Okay, so and determinants are only applicable for a square matrix. No? For a square matrix, the number of rows is the same as the number of columns. So note that only a square matrix has a determinant. Okay, so this is the notation DETA or DET. Then we have open parenthesis A, then close parenthesis, or we have the symbol, no? So two parallel lines, and inside it is the matrix, no? So let's start with finding the determinant of a 2 by 2 matrix, no? So the scalar value of the determinant of a 2 by 2 matrix is the product of the elements on the major diagonal minus the product of the elements on the minor diagonal. Okay, so it's only a scalar value, meaning it does not have direction, magnitude only. No? So it's scalar. No? So in this case, we have the determinant of A equals to this notation. Okay, equal to, so this is now the 2 by 2 determinant. No? Okay, so we use parallel lines. No? And inside it are the elements of the matrix. No? So we have A11, A12, A21, and A22. No? So in this case, so we simply multiply A11 and A22. Product of the elements on the major diagonal. Okay? Minus, okay? Minus product of the elements on the minor diagonal. Okay? So minus that. Okay? Simply as that. No? So for example, so this will be 3 times 1 minus 6 times negative 2. No? So 3 times 1 minus 6 times negative 2. Okay? And the answer is 15. So for a 3 by 3 determinant, if we have this matrix, now, so this will now be the formula. No? So this was derived using basket method or nest method. No? So it's just easy. No? Let's say if we have matrix A, so we write the elements. Okay, so we determine the matrix, the determinant, no, of that matrix. Okay, so we determine the determinant of matrix A. So we simply write the elements in the first column. Okay, we copy the elements in the first column and as well as in the second column. Okay. Next, we evaluate now the determinant. So the determinant of A. So we have the product. No. So we have A11, A22, A33. So going up, that is positive sign. it will have a positive sign. Okay, going down, so positive sign. So it's the sum, no, summation, A12, A23, A31. Okay, then this one, so positive sign, so plus A13, A21, A32, no? Then we go upward, no? From left to right, we have upward, no? So we have A31, so then there will be a negative sign, so minus A31, A22, A13. Then upward from left to right, negative sign, so minus A32, A23, A11. No. Then upward, minus sign, no? A33, A21, A12. That's it. Then we can factor out. So we can factor out. So A11, A22, A33 plus A12. O ito na lang. Huwag ko na yung sulat. Nakasulat na dito. Okay. Ito siya. A11, A22, A33. A12, A23, A31. No. Then A13, A21, A32. Then pinactor out yung minus sign. Okay. Pinactor out yung minus sign. So A31, A22, A3, A13. Ito siya. Then A32, A23, A11. Okay. Then ito. So ganun lang siya, no? Pero syempre, merong mas madali dyan na shortcut, no? Hindi na kailangan na pagdating dito, pwede ng diretso. Hindi mo na kailangan gawin yun. Yung maglalagay ka pa ng first and second column, no? So ganito lang yan. Okay, so multiply A11, A22, A33, then plus, I think naturo ko na yata sa inyo to dati. A12, A23, A31. Sa vector, sa physics, I think. I have introduced this before. A13, A21, A32, no? And then upward naman. Okay. Upward minus quantity. A31, A22, A13 plus ito A32, A23, A11. Okay. A33, A21, A12. There. So, nakompleto na, no? So, ito yung basket method or nest method. Okay? So, example, solution. Ganyan lang yan. 2 negative 2 times negative 2 times negative 2. Ayun. Then 3 times 3 times 3. Ito. Then negative 1 times 1 times 1. Ito. Minus, paakyat. No? Paakyat naman tayo. 3, negative 2, negative 1, 1, 3, 2, then negative 2, 1, 3. Then 28 will be the answer now. So you can try example 2. Okay, so you can try example 2 and the answer will be 12. Okay, so that will be the answer. Well, alright, so before I proceed here, you can actually use calculator. No. So you can use your calculator if you want. No. So if you have this calculator, so I'm encouraging you to have a calculator during exam for those who don't have laptop. No. So kasi mag-solve tayo using calculator. So kahit hindi mo na gawin yon, meron naman shortcut. So meron siyang mode matrix, mode 6. Okay? So go to mode 6. Let's say mat A for matrix A. Okay? And it's a 3 by 3 matrix, right? So press 1 and you may insert the values. Negative 2, then 2, negative 4, okay. Uh, so 1, negative 1, 5, 5, negative 3, and 0. Okay, and then press AC, then shift 4, then 3, matrix A. Okay, so we verify. Negative 2, 2, negative 4, 1, negative 1, 5, 5, negative 2, 0. Okay. Let's evaluate the determinant. Okay. So shift 4, uh, determinant 7. Determinant of shift 4, matrix A 3. Okay. And we get 12. So 12 is the answer. Okay. So let's check this one. So you will get 28. You may try, no? You may try, you will get 28. Okay. So however, the limitation of this calculator is it can only handle ano nangyari? Wait lang So it can only handle up to 3 by 3. Walang 4 by 4, walang 4 by 5. So that's the limitation. So pwede ka rin dito mag matrix multiplication if I'm not mistaken. Although di ko pa na-try. Pero dyan lang ang kanyang limitation. Kaya na-encourage ko kayong gumamit ng Microsoft Excel. Kasi yun ang extension ng calculator. No? Yung pwedeng ma-extend using Microsoft Excel. So kailangan ng skill sa pag-simulate. No? Sa pag-simulate. Tututuro ko rin yun yung process. Okay? So in that case, Kayo na lang discover kung pwede siya ng matrix multiplication. Pero alam ko pwede siya. No? Yung mga previous example natin, you can apply. No? Matrix multiplication. If I'm not mistaken. No? Kahit addition, subtraction, pwede rin siya, I think. Alright, so we can proceed. So determinant using cofactor method. So this is beyond 3 by 3. We can able to apply cofactor method for any square matrix. No? For any square matrix, pwede ang cofactor method. Kahit 2 by 2 yan, 3 by 3, 4 by 4, 5 by 5, or whatever. Basta square matrix siya. Pwede. At dyan napapasok yung programming or simulation sa Excel. Paano natin magagawa now. So, determinant of A is, ito siya, yung formula niya, summation, Aij, Aij, no? So, ang Aij is the element of matrix A in the ith row and jth column. Aij's we call as cofactor. Cofactor in the ith row and jth column of matrix A. No? At ang cofactor, ito yung formula niya. Negative 1 raised to the power of I plus j multiplied by Mij. Ang M, ang tawag dyan, minor. Okay? Minor. Mij equals to the minor. Ang minor na yan, yun yung determinant na matrix na may size na n minus 1 by n minus 1. Okay? Yan ang size ng ating size ng determinant n minus 1 by n minus 1. Okay? Later, I will show you in detail kung paano yung minor. So, in the ith row and jth column of matrix A, of size n by n. Okay? So, later, I will show you paano to. So, for example, if I have this determinant 3 by 3, okay, I will select on ith row of matrix C. Let's say I chose 1, I equals to 1. First row, I chose first row, row 1. Okay. So, in the ith row, so say I equals to 1. So, we have this formula now. We will evaluate the determinant of C using the cofactor method, applying this formula. Kasi yung ating original niyan ay determinant of A, summation, Aij, Aij, right? Ang Aij, yan yung element in the ith row, jth column. Okay? Tapos yung Aij na to, ito yung cofactor in the ith row, jth column. So, yan yung cofactor. Okay? So, in that case, let's apply. So, we had selected I equals to 1. No? We select I equals to 1 kasi row 1 yung ating naging reference. So, this will now be the formula. So, C11, so this is C11. This is C12. And this is C13. First row, first column, second column, third column. Okay? And then, cofactor C11, cofactor C12, cofactor C13. So, anong formula niyan? Yung may negative 1, no? Ano yung Aij? That is negative 1 Mij, right? To the I plus j. So, yan ang formula. So, similarly, Cij is negative 1, okay, I plus j, mij. Okay? So, ito ngayon yung kinalabasan. Kasi 1, 1 eh. So, 1 plus 1, ito siya. Mij, M11. Ito, M11. Okay? Then, C12, 1 to 2. 1 plus 2, M12. Okay? Ayun. Then, C13. C13, negative 1 raised to 1 plus 3. Okay? And then, M13. Ayan. So, yun ang lumabas. So, the minor, how do we determine the minor? Ito siya. Okay, paano na lumitaw yung mga values na yan? Ganito lang yan. So, M11, how did we determine this determinant? Paano naging ganito yung determinant? So, meron tayo ditong first row, first column, 1, 1. Minor in the first row, first column. First row, okay, row 1. First column, column 1. So, ito ngayon yung ating gagamitin. M11 is the determinant, negative 1, 5, negative 3, 0. So, this will be deleted. Madi-delete. Tapos, ito kukunin natin yung determinant. Anong size niyan? 2 by 2 na lang. Ito, 3 by 3. So, kaya, ang size ng minor, n minus 1 by n minus 1. Okay? Mas mababa ng isa sa original. So, 2 by 2. Okay? So, that's why nakuha natin ito. Okay? And we can also consider this one. How did we get this? So, mayroon tayong M12. So, delete row 1 and column 2. So, row 1, column 2, ito, 1550. Ayun, 1550. Ayun, 1550. I hope you can follow the discussion. And then, we have M13. Okay, delete row 1, column 3. So, we have that. 1, negative 1, 5, negative 3. Evaluate the determinant. Okay? So, then the determinant now will give us an answer of. So, ito, ang magiging sagot ay 12. Okay? So, the answer will be 12. Okay? So, yung 2 by 2, naturo ko na yan. Okay? Basket method lang yan. Negative 1 times 0 minus negative 3 times 5. So, madali na yan. So, mag-a-arrive ko sa 12 na sagot. So, that is for cofactor method. So, we have this problem. Solve for the determinant of the 4 by 4 matrix below using cofactor method. Okay? So, this is the matrix C, and we're going to determine the determinant. So, to determine the determinant, we have to recall the formula for the cofactor method. Okay? And also, aside from the formula that we have to recall, we are to select the row that we desire, no, in our solution, selecting an ith row of matrix C. So, the matrix has 4 rows, and so it has 4 rows. So we will consider the second row. Okay, so this will be a reference, the second row. Okay, row 2. So we had selected now the second row. Okay, so the determinant of C is equals to summation of Cij. Again, this is the formula for finding the determinant of any square matrix regardless of the size. This is the formula. Okay, so we have summation lowercase c with the subscript ij multiplied by uppercase c with the subscript ij. Okay, so initially that is determinant of a. I have shown you the formula for that. So that is determinant of a. A yan. Then summation aij, aij. So anong tawag sa cij na to? At anong tawag sa malaking C? Do you still remember? So tawag dito ay na yung C na malaki, cofactor, no? Okay? So yung C na maliit, element yan at the ith row and jth column. Okay? So just like in my discussion previously, no? So we can proceed. So we had selected the second row, no? So sinelect natin yung second row. And in that case, we will replace now I by 2, no? So we replace I by 2 because we have selected the second row. Next, so this is summation. So in other words, we will sum up certain terms. Okay, so this is C21. So we begin with 1. Okay, we begin with 1 and will end at 4 because J here represent the jth column. So we have 4 columns in our matrix, no? We have 4 columns. Okay, and that is from 1 to 4. Okay, we have column 1 to 4. So with that, we now proceed with the next step. So we determine, we simplify, we expand. Now we expand this quantity. Okay, expanding it, we have this. Okay, so recall the formula. No, so aij is equals to -1 raised to I plus j mij. Okay, and we call m as the minor in the ith row jth column. We call m as the minor, no? So it is a determinant. This is determinant with a size of n minus 1 by n minus 1. N minus 1 by n minus 1. So that is the size of the determinant. Okay, mij. Now the size of the minor in the ith row and jth column. So matrix C here is an n by n matrix. So meaning this is 4 by 4. It has 4 rows and 4 columns. So for the determinant, for the minor, that will be 3 by 3. Okay? So that will be the size of the determinant, 3 by 3 determinant. Okay? So we apply now. So we have 2 plus 1, then m sub 2 1, and okay, same pattern. Okay, so that's the pattern, and we proceed. So in evaluating the determinant, okay, so we get 9828. Okay, we get 9828. So how did we arrive with this determinant? Again, in my previous discussion, we consider the second row. Okay, we consider the second row. This is row 2 and column 1. Okay, so this is column 1. Column 1. So we erase column row 2 and column 1. Okay, so in that case, what is left are the elements 18, 33, 17 that will be written here. Then we have 1, negative 126 written in the second row, 19, 11, 36 written in the third row of the minor. Okay, minor in the second row, first column. Okay, so and in that case, the result will give us 9,828. In my previous discussion, I have already showed you on how to determine the determinant of a 3 by 3 with size 3 by 3, no? Determinant of a matrix, no? With size 3 by 3. So, and we apply the conventional way, the basket method, on how to determine the determinant of this. Okay, and also I have showed you the use of a calculator. Okay, that can solve the determinant, no, of a 3 by 3 matrix. Okay, I have shown you that before. Okay, so later I'll show you again on how we arrive with this value, no, using the calculator. And then for the next minor in the second row, second column. So we eliminate the second row and the second column, and what will be left are as follows: 7, 33, 17, negative 9, negative 126. Okay, then 30, 11, 36. Okay, and we will arrive with this answer. Okay, then for the third one, we have 13 to 49. So second row, third column. Second row, third column. Okay, so 7, 18, 7, 17, negative 9, 126. Okay, 30, 19, 36. Okay, and then for the second row, fourth column, we have 7, 18, 33, negative 9, 1, negative 1, and 30, 19, 11. So those are the values. Okay, so and we will arrive at this answer: negative 726, 723. Okay, so again, let me show you the using the calculator. Okay, so we have mode matrix. Okay, so we input the values for the matrix. So let's try matrix A and shift. Matrix A, shift for data. Data for matrix A. It's a 3 by 3 matrix, right? 18. So let's choose this one. M22, 7, 33, 17. Okay, negative 9. Okay. $36. Okay. Then press AC. Shift 4. Okay, press 7 for the determinant. Then shift 4 again. Then 3. Then equals. So we get 33,005. No? And then just substitute. No? So just substitute the values. So okay, so you see C21. So second row, first column, 15, 15. So let me show that. So 15. Okay, so this is C21. This is second row, first column, C21. So this is 15. Okay, then this is 9828. Okay, and then this is negative 3. Okay, and then this is 33,005. No? Okay, then second row, third column. Okay, that is 21. Then this one, 13,249. Then we have this one, 39. Okay, 39. So this is 39. Then M24. Okay, and you will arrive with this answer. I hope you get it.